at learning plan number 5 here, there was a question about creating the STL file. So before I get to opening up Creo and doing that, I just wanted to remind us that all the details in terms of machines that are available, sizes, cost of material per cubic inch, all that kind of stuff is right here at the top of the learning plan. So what you're going to do is you're going to create a Creo model. You can use an inspiration like GrabCAD or Thingiverse, but you have to create your model using what you've learned this past semester in Creo. Once you have that created, you're then going to export it to a 3D printer. And for the 3D printers to be able to read it, you need to create an STL file. So part of my demo today is going to be creating that STL file using Creo. But I wanted to let you know that you have the FDM machines available to you in our lab. So the Enders machines, the Stratasys 170, the Uprint, and the MakerBot are our FDM versions. And in back of these and underneath, you'll notice that I have the build envelopes that you have available. So that's going to be the size maximum that you can, take up with your part. Additionally, there's going to be the material underneath here. Now, what I do need you to do is I need you to find the volume of the part and of the material that you plan on using, and you're going to then need to determine how much of that material and what it's going to cost. So you'll do a calculation for the model and or support material depending on the machine that you choose. So I would suggest getting together with John Pelland, who is our Fab Lab director, and he kind of runs things, if you would, in that lab. He can help you pull it up in the slicing software that the 3D printers utilize, and then you can get exactly how much material and or support material is going to be needed for your project. Now, you have $25 to spend, okay? So whatever technology you decide to use there, or whatever material, then once you know what your volume is, you can determine how much is there. So you have a $25, if you would, credit on file here, and you can print, using that money. Now, I want you to know that if one part, for instance, is 1 cubic inch, that means that you would technically have like 25 items that you could create, okay? So you can print more than one if you so chose, or you can, just use whatever. So I just want to make you aware of that. Now, once you have your cost figured out and you know exactly what machine you're going to be running it to, make sure that you submit your Creo and your STL file that gets you 20 of the 30 points for this project. And then submitting your cost calculations will get you the next 10. So the total assignment for Learning Plan 5 is worth 30 points, 20 for the model and the STL, and 10 for the cost calculations. So if you have any questions on that, let myself or John Pelland know, our Fab Lab director. He's available anywhere between like 8 and 3-ish, Monday through Friday. So he will be, kind of here to assist you as needed. Now, be aware that it's kind of first come, first serve, or make an appointment with John. I do have his email listed here, so feel free to contact him directly if you have a specific time that you're needing to make that happen. Okay, so let's look at how do we create an STL file out of Creo. So I already have Creo pulled up, and I am just going to, you're going to design your part, and I'm just going to open one of my parts here. So I'm going to grab the 4-hole hub. I'm going to say open, and here is my part. Okay, here's my part. Now, the slicer software is going to orient it on the bed. You can scale it over there in the slicer software, but all you need to do is create your STL file, okay? So to do that, it's going to be a save as function. So we're going to go up to File, just Save As, click Save As.
Making sure it's still in there working.
Save As. There we go. I don't know why it didn't go on my first click, but you do the Save As function, and then you need to navigate to where you want to save your STL file. I would suggest just saving it right by the actual part that you created, but it's not, it's not required. You can put this really anywhere you want it to go. You will need a copy of it, just the STL file on a jump drive when you go to print the file, because we don't have a place right now where on the network where we can access or save the files and then get them in the Fab Lab. So you need to be a little mobile with it and put it on a jump drive. So, so you would navigate to wherever you want it to go. I'm just going to put it on my H drive here. And then down here, it's in the Save As, I need to change my file type. So I'm going to use that arrow down. And then I'm going to go down to right about in the middle here. It's a stereolithography or an .stl file. So I'm going to click on that. And then over here by options, to the right of it, we need to customize the export, okay? Once you have the customize the export checked, okay? And if you don't check this, it's gonna look different. So make sure you have that checked and you're gonna hit okay. It says that it already exists, I know, okay. And we wanna write over it anyway, because I already did this process. Now, over on the right-hand side here, this menu is gonna come up. If this menu doesn't come up, you didn't check the custom export, okay? We want to customize this. Now, if I hit apply right now, you'll notice that they have a chord height, okay? I'm going to apply it. You can see what happens. It creates all these triangles around my part. And if I kind of zoom in here, you'll notice that at this level that we have identified here for the chord height, about a 32nd of an inch, you'll notice that there are these lines that when we have circular features, it's going to kind of, I don't know, it's kind of along, like that's going to be the look of the whole. It's not going to look perfectly round or smooth. It's going to have these lines on it, okay? Now, when we create parts, you are going to have those lines there, but if they're smaller or larger, it's going to depend if you really, see that. So let's adjust the chord height to be smaller than a 32nd. So I'm going to put in 0.015, about a 32nd, if you would. Or I'm sorry, about a 64th. So I'm going to hit apply and notice what happens. So hopefully you could see that. These lines got shorter, okay? I can make this even smaller, 0.0, let's say 0.8. And I'm going to hit apply. And I keep doing that and kind of adjusting until I can get, kind of the definition I want. I will let you know as these increase, you'll notice that the number of lines and facets increased. That's going to increase the file size and it's going to take longer to print, okay? Just so that you know. So there's got to be kind of a happy balance here. So I think right around 8 thousandths looks pretty darn good because that's going to be what my final part looks like. But you could, like I said, you can make these really close together. So for instance, if I take 0.001 and I apply that, notice how close they get together here. And again, my file just got bigger and it's going to take longer to print. Okay, so so just be aware of that. So I think 8 thousandths is pretty good for, especially if I'm doing an FDM file. It's not like capability wise super duper accurate. So I think 8 thousandths is a good number and it's going to get me kind of the definition that I want, where it still looks round, but it's not like crazy on the data. Okay, so once I have that applied, I can say, okay, and that's the only thing that I need to adjust, okay? The default is gonna be that 32nd of an inch-ish, okay? And then you can adjust from there. Now, if the 32nd of an inch is totally fine with you, great, okay, great. But like I said, I think it's a little bit nicer at a smaller number. Now, once I have this and it's saved, and mine is saved in the place that I have it, that's where I wanna take that STL file then to the Fab Lab and work with John on getting that the amount of material that's going to be used when it's actually made. Okay, so that's all that I have. And then make sure that you upload the STL file and your Creo file, the Creo part file, and then you will be all set for this learning plan. So as I look back over here, you will submit then in the homework here for learning plan number 5, and the Dropbox is here for the cost calculations, and then down here is for the Creo model and STL file. Okay, so that's all that I have for you on this. I'm going to stop sharing and stop recording. If you need anything, don't hesitate to reach out.